Hey guys, welcome back. Somehow my video shut off. Sorry about that. Okay, so we'll finish out the problems here. Question 8, which one does not result in some kind of bias? So here, choosing AP students to survey regarding their GPA in order to estimate the GPA of the whole school. That's not going to work. Mostly honor students take our class. So if you only surveyed the AP students, you're probably going to get in higher in average. Polling a group of potential voters outside a Republican campaign. Yeah, so that's like a convenience sample. You're going to get more Republicans than you would otherwise. Surveying people who work in a marketing department in order to assess all the employee satisfaction, that's not going to work. We need to ask everyone if we're interested in making an inference about everyone. Choosing a stratified random sample of juniors and seniors at a high school in order to estimate the proportion of juniors and seniors who plan to go to college. We know that this one's good. We know that choosing stratified is an appropriate, so stratified is appropriate way to sample. And they kept in line, they sampled the people that they're interested in making an inference about. Asking shoppers leaving a grocery store, yeah, that's a convenience sample, so that one's not going to work. Okay, because they're interested in making an inference about how people feel in the whole city. A church board wants to survey church members to see which times they prefer to have service. The board wants to ensure members have families as well who are singles, adults, are represented in the sample. Which method will yield the best chance? Okay, so they want to hear from everyone. And so that means that we're going to want to do a stratified, because if we just randomly pick from the whole group, then we may accidentally leave out certain groups. And so that's why we want to separate in single groups and do a random sample from each of these lists. And this will help yield a representative sample from their members, representing each strata. All right. So make sure to write down something, a sentence, a half a sentence that's kind of summarizing our answer there. Which of the following are false? Okay, so we're looking for falsing here. The convenience samples are rarely useful. Yes, this is correct. So if we picked C and D, we would have picked one as false, and we know that to be true. Every good experiment includes blocking. That's false. There's lots of experiments that don't necessarily include blocking. So we're down here to B and C. Every experiment we know that every experiment doesn't have to include placebo. It's just useful. So again, what do we write? We say use of placebo and blocking aren't required. They're useful though. They're not mandatory. Nice. 11, what is double blinding? Our notes say that double blinding, so just kind of rewrite the definition to kind of stick it in your brain, to keep the knowledge of the treatment from influencing the response or the measurement of the response. So that is why double-blind experiments keep both the subject and the person measuring the response. It does this because it keeps the subject and the person measuring the response from knowing the treatment. All right, 12. A car manufacturer is concerned about time it's taking for batteries to be installed on the assembly line. The use of the new tool has been suggested to reduce time spent on this part of the assembly process. Which of the following would be the best way to establish if this new tool reduces battery installation time compared to the old one? All right, so let's see, we read through here and we see if we have each worker use both of the tools for each day, each worker flip a coin. Yep, we want to randomly assign whether you're using the new tool or the old tool. So we have our workers, right? And we want random assignment for them to either end up using the new tool or the old tool. And we know we have to have random assignment. We also want to randomly decide whether you use the new tool. If you do, it looks like this is a matched pair. So if you do a matched pair and each person is going to use both, then the only way to kind of put in some random assignment piece is for them to randomly use one or the other first. All right, because there may be a preference for just the first one you used worked, and so you're like, yeah, the first one's fine because it worked, so why do I need the second one? So to avoid the preference of preferring the first or maybe preferring the last one you used, we want to randomize in that way because we know within each experiment we need some type of randomization. 12. 5,000 menopausal women are participating in a biofeedback regimen to see if this will help relieve symptoms. Half of the women were randomly assigned to a group that received biofeedback regimen, while the other half were assigned a control group. Okay, so we had our women, and we used random assignment to either give them biofeedback or a control group. And again, we need the control group here is useful so that we can see if it really is the biofeedback. Is this an observational study? Well, no, there's a treatment there, right? So we see that this is explained as a simple randomized comparison. I'm comparing between the biofeedback and the control group. We have no information of blinding. In fact, it would be hard in this example because you know whether you get the feedback or not. And so double blinding is out of the question. And match pair would be if you got nothing and then you got the feedback in pairs. So each woman would actually get both treatments or lack of treatments. So B is the best. All right, almost done here. 14 says, the math department wants to see if the use of a software program will improve geometry scores. The department has to decide to set up 2 smaller experiments with 10 sections in geometry. 2 teachers have volunteered to have their students participate. Ms. Smith is going to use the software along with the classroom materials. Ms. Jones is going to just use the classroom materials. Each teacher will use 5 sections taught in periods 1 through 5. Students will be given a pre-test as well as a post-test. What are the treatments? Okay. So what are the students either given or not given? So it looks like they are given this software or not given that software. So that has to be a treatment, right? And that's actually one of our choices here. So we're going to choose it. Last, the math department wants to see if the use of this software will improve the scores. The department decided to set up 2 small experiments, 10 sections, 2 teachers, so it's kind of same scenario here. Smith's going to use the software, not going to use the software, each teacher 5 sections. The students will be given a pre-test and post-test. Okay, same thing. What variable is confounded in the treatment here? Okay. Notice, and this one's like the sunny and non-sunny section. We're worried that it could be this sunny or not sunny. So in this instance, we're worried that it could be the teacher. We also know that data shows that certain teachers actually produce better grades regardless of methods, that it's the teacher themselves that would confound that. Just like the sun itself could be the one making the plants grow more. And that's a good analogy for teachers, isn't it? Making their plants grow more. So it is, in fact, the teacher themselves that's confounding. So if we look at here, does the software, we're trying to decide as an explanatory variable, does software explain the response, better results? But in fact, could it be the teacher that's influencing both of these? And so it's really hiding the information you're looking for. Nice job, guys. Good luck studying. See you next time.